All right, so here's this question. The equations represent a circle and a line that intersects the circle across its diameter. What is the point of intersection of the two equations that lies in quadrant 2? Lies in quadrant 2. Well, first of all, to be in quadrant 2, which is here, then you've got to have a negative and a positive. So that's the first thing. So what that does is that knocks out letter C. Because the rest of these are in quadrant 2. So let's go and let's do some algebra now. As with so many problems on the SAT, you have to set up a system, and this system's ready to go because we know what y is in terms of x. Y is negative x plus 2. So you just got to shove it in right there, and you got to do some algebra. So we get x minus 2 squared plus negative x plus 2 squared equals 36. So keep going, blast through with algebra. X minus 2 times x minus 2 is x squared minus 4x plus 4. Next, negative x plus 2 is x squared minus 4x plus 4 equals 36. So from here, combine like terms. X squared is 2x squared. Negative 4 and a negative 4 is a negative 8. 4 plus 4 is 8. And I'm going to go ahead and bring this over because this is a quadratic equation. Anytime it's quadratic, we need to set it equal to 0. So minus 36 equals 0. So this gives us 2x squared minus 8x minus 28 equals 0. Now, hopefully the next thing you see is that every single one of these numbers is divisible by 2. So, goodbye, goodbye. Take the 2 out, which takes us to x squared minus 4x minus 14 equals 0. So, from here, you just got to solve this quadratic equation, which you could use the quadratic formula or you could use the shortcut, which is completing the square. X squared minus 4x plus 4 equals 14 plus 4. X minus 2 squared equals 18, square root, x minus 2 equals plus or minus 3 root 2. So x equals positive 2 plus or minus 3 root 2. So when you look in the answers, which one of these gives us 2 plus or minus 3 root 2? It is D. Now obviously it's not 2 plus 3 root 2 because that would take us into quadrant 1. But if we say 2 minus 3 root 2, that takes us into quadrant 2. That's why D has to be the answer for that particular problem. Next problem. Same page that you sent me. So if the radius of a circle above is x and angle AOB is equal to 120 and O is the center of the circle, what is the length of chord AB in terms of x? So you got all this kind of stuff, and I was trying to do it in terms of x, and then I was like, nope, let's think about it a little bit differently. So first thing I see is this 120. This 120, because these two sides are radii. If I bisect that angle, because it's basically what we've got here is an isosceles triangle. If I bisect that angle, then I end up with a 60 and a 60 making both of these 30, 60, 90 triangles. So what if I let the radius equal 10? It's always easier if you plug in a real number rather than just x. We can always take that back out on the back end. So let r equal 10. Remember, powers of 10 are always the easiest things to plug in. So now, if I want to know the length of that chord, if my hypotenuse of my 30, 60, 90 is 10, my short side is 5, and my two longer legs are 5 root 3. So if we've got the length of the chord, it's 10 root 3. So remember, we let the radius be 10. And if I go back and read the problem one more time, it says, let's see, blah, 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 if the radius of the circle above is x, all right? Maybe I shouldn't put r there. Maybe I should put x there. So if we let x be 10 and our AB is 10 root 3, doesn't that mean that our radius, or excuse me, our chord AB is x root 3? Which it is. And x times root 3 is exactly the same thing as root 3 times x. That's why the answer has to be B. So I went to the interwebs and looked up this problem, which is truly where you can look up almost every single one of these problems and find a solution. The function g is defined by g of x equals 2x squared minus dx minus 6. D is a constant. If one of the zeros of g is 6, what is the value of the other zero of g? Well, let's think about it. This is one where you kind of got to look and go backwards. Remember, if you're talking about zeros, then first find functions. So if one of your factors of your function is x minus 6, how do I know it's x minus 6? Because if I said x minus 6 equal to 0, I get 6. That's how I know that x minus 6 is a factor, because it brings about a 0 of 6. So what does the other factor have to be? Well, x times what is 2x squared? X times 2x. And negative 6 times what is negative 6? A positive 1. That means that 2x plus 1 has to be the other factor. And if 2x plus 1 is the other factor, then 2x equals negative 1 and x equals negative 1/2. That is why C is the answer. That is a brute force Algebra 2 problem.